Hey folks, can everybody hear me?
Yes.
Okay, so I noticed that a lot of you have your microphones turned off and video turned off. So there's also the chat room. So you can type anything you want in the chat room. So first of all, we want to go through a review of Unit 3. So where should I start? Anybody have any preferences? Okay, go over the homework, go over a chapter. Anybody have any preference?
No. It just start from the beginning.
Did you post like a kind of like a study guide, like how you did for the other exams, or?
Yeah, I did.
Okay, is it in the? Okay, I see it in the chapters folder, right?
In resources in the chapters, yeah.
Okay.
I'm still a little confused about figuring out if it's a redox reaction or not.
Redox reaction?
Yeah.
Okay, so do you know about how to assign oxidation numbers?
I feel like I'm not clear because I tried to do it, but I still like don't know if I'm doing it right.
Okay, let me see.
So that would be like homework 14.
Yeah, maybe I should just go through the homework then.
You know that table that like, I'm sorry, the table that lists the oxidation number rules, and like it tells you to follow that order. Do you like use that, or like, because I don't see that in your notes, so I'm guessing like you don't. I know you do things a little differently, so do you recommend not using that? Because that's how I learned how to do it in chemistry.
You mean to memorize the list of oxidation states?
No, you know that table, like it says like first, like everything that's a single molecule is 0, and then hydrogen with anything is a +1. And then it's like kind of like a list of rules, and it tells you to memorize the order so that like that's how you assign the numbers. Because that it works. That's how I do it, but like.
So you weren't getting the numbers just directly from the periodic table?
I did do it that way too, because I know that's like how you suggested it, but like in chemistry, that's how we did it with that table.
Yeah, they want you to memorize stuff.
Yeah, well, I kind of just memorized like the hydrogen, the oxygen, and that's pretty much it. And then everything else kind of falls into place. But I don't know. I think that I know that you teach it differently, so you're saying just pull it directly off the periodic table.
So,
And then I know you said the more electronegative number is going to be the negative number.
exactly.
Yeah.
Right.
Okay.
So if you look at, let's just take sodium, for example, right? So if you look at sodium, I don't know how this works. If you look at sodium, there's only one number there, that's a +1, right?
Mm-hmm.
So if I have the element sodium, elemental sodium, the number is going to be 0 because it's an element.
Right.
And now the only thing that sodium has ever been known to do is form the +1 ion. So that's its only possible oxidation number. It's not going to form the +2, it's not going to form a -1. And it goes back to electron configuration. What does sodium want to do to become like a noble gas? And that's lose 1 electron to be isoelectronic to neon. So these oxidation numbers are really all about happiness. So now if I have a molecule like sodium chloride, right? So sodium is going to be +1. That means that chloride has to be a negative number. So I look at the oxidation numbers on the periodic table for chlorine, and the only negative possibility is a -1. That's all they can do. Does that make sense?
Yeah.
So what if I have a molecule like carbon dioxide? Now I have the possibilities of what carbon will do, what oxygen will do. But how do I know which one is going to be positive and which one is going to be negative? Then I have to think about electronegativity. Oxygen is way more electronegative than almost anything. So that means that oxygen is going to be a negative. Right? So the only negative possibility, for the most part, is a -2. So that means that carbon will have to be positive. And carbon can be a +4, it can be a +2. And those are your only possibilities. So if I'm looking at a, let's see, what is one of the things that did that? Let's see if this will work. Wait a minute. Okay, so you're seeing my screen now, right?
Yeah.
Okay, so if we look at this problem number 1 here, so I'm asking, is it a redox reaction? Yes or no? And what I see is that calcium is a +2 over here. Calcium is a +2 over there. So what did calcium do? Nothing. It didn't lose or gain electrons.
Yeah.
Here's phosphite and another phosphite. Phosphite didn't do anything. So this is a double displacement reaction. So you can either memorize that they are not redox reactions, or you can go through that process right there and see that nothing changed. And so let's see, let's find a single.
And you said that on the exam we're not going to have to make products, correct?
Not going to have to what?
Like make predict products like this?
No.
Okay. I mean, I know I should know how for future, but I kind of don't know how. That's the one thing I could not like figure out really.
Okay. No, it's really not hard, but it is an extra thing that we don't necessarily need to do right now.
Yeah.
So anyway, here's a single displacement reaction. So if somebody asks you, is this a redox reaction? You could say, well, yeah, all single replacement reactions are redox reactions because I memorized it. Or you can say, well, here's magnesium. It's an element. Its oxidation, therefore, is 0. And I come over here, and in the molecule magnesium sulfate, sulfate is a -2, so magnesium has to be a +2. So what happened to magnesium? It went from a 0 to a +2, meaning that it lost 2 electrons, so therefore it was oxidized. Make sense?
You know how you say too, like the reaction will go from left to right because iridium is stable, more stable than magnesium. So that will be true for like any reaction that has a jewelry metal as a on the left, and then something less stable, more stable on the right.
Right.
Okay.
So the whole idea is this part reactive compared to this.
Okay.
So here we went from something that is fairly reactive,
Okay.
something that is pretty inert.
Okay.
That's going to happen. Same thing over here with a combustion reaction. This is very reactive. It's a high amount of potential energy. Throw a match on it, it blows up. But if you got CO2 and water, you throw a match on it, the match just doesn't do anything. So this gets to be more stable.
And it's exothermic, right?
Exothermic, yes. We give
How
off
can,
heat energy.
how can I tell that it's exothermic?
Because if I put a number over here as a product, like say 500 kilojoules or something, that would tell you specifically that it's giving off 500 kilojoules for every 1 mole of benzene. But we know that if you put a hydrocarbon and an oxygen together, they blow up. We know it gives off heat. It's like gasoline in your car. Does it give off heat? Yeah, so we know it's an exothermic reaction.
Okay.
So with this one, now you're comparing essentially aluminum to gold, right? So yeah, you're getting more stable as you go in that direction, so it will happen. If I had this in reverse, this reaction right here, would you be able to tell me that that would not happen? If I took gold, which we know is very inert, which means it's very stable, and I put it with something, am I going to make it react with something?
No.
Probably not. Okay. So what's the oxidation number for oxygen right here?
0.
0. And what does it say in water? What's the oxidation number for oxygen in water?
-2.
Should be a -2, right? That means that oxygen, excuse me, that means that hydrogen would be what?
+1.
+1. So what happened to oxygen then?
Reduce.
It got reduced, right? What kind of a molecule reduced it? Maybe a reducing agent, which means that C6H6 is the reducing agent. So what's happening to C6H8? It's getting oxidized, right?
Yes.
So now if you look at, and this is like something I wouldn't necessarily ask you, but I want you to see that this is a system that works. I look on the periodic table or electronegativity values, and I see that carbon is more electronegative than hydrogen. So what would be the charge on carbon? Positive or negative?
Negative.
Most likely it's going to be a -4, right? And hydrogen will be a +1. Now I come over to carbon dioxide. So which one is going to get positive and which one is going to get negative? In carbon dioxide.
Carbon. Carbon will get positive.
Oxygen is by far the most electronegative, right? So it's going to get negative. So that means that carbon has to be positive. It can either be a +2 or a +4, but it doesn't really matter. You went from carbon being negative to now carbon being positive. So carbon got oxidized. And what oxidized it? The oxidizing agent, which is oxygen. Trying to find a way to right. Playing with my settings over here. Okay. So does that kind of clear up your questions about oxidation numbers and redox reactions?
Yeah, it helps. Thank you.
Okay, anything else that we should review?
I have a little bit of trouble figuring out whether or not a molecule is symmetrical,
Okay,
because I know that there's some exceptions, like in tetrahedral molecules, and then how it relates to their polarity.
okay. My toys. Okay, so let's look at this one here. So we have two central atoms that are blue, right?
Mm-hmm.
So if I look at each blue one, it has 1, 2 regions of electron density, right?
Mm-hmm.
So the shape should be linear,
Mm-hmm.
and the bond angles would be 180 degrees.
Right.
So this carbon is the same as this carbon, right?
Yes.
So now I'm looking at the entire molecule. So the entire molecule is linear. So the question is, and I just noticed one more thing here. Let me just make this. Is this molecule symmetrical?
Yes.
So does it matter whether this is a polar covalent bond? If these are the same?
No.
It's going to be a non-polar molecule no matter what, right?
Mm-hmm.
Because if this were a rocket and this were a rocket and I fire those rockets at the same time, it's not going anywhere. So it has no net dipole. It's a non-polar molecule. But now, what if I change one of these atoms over here and I tell you that this right here is a polar covalent bond. This one right here is a non-polar covalent bond. So is it a symmetrical molecule? White one, green one.
So 2 different bonds, right?
Two different atoms on the ends.
Yeah. Okay. You
So
It's not symmetrical.
So it's not
Green.
symmetrical, right? So if this is polar and this is non-polar, there's nothing to cancel out this rocket. So the rocket will just make the molecule move and it's a polar molecule.
Mm-hmm.
So this molecule is likely to dissolve in water, not likely to dissolve in oil. Okay. Let's find another one.
So like say it was like a linear molecule like that, but but one side was a double and one side was a single bond, would that be unsymmetrical?
It depends on whether it had resonance or not. You have to look at the molecules.
Like if it was like
Let's see.
like CO2 is CO2 is symmetrical. Oh no, that's 2 double
Yeah,
bonds.
CO2 is symmetrical.
What about SO2?
SO2 should be bent, I think, right?
Oh
So-
right.
So
Then
SO,
asymmetrical, right?
yeah.
Yeah, because does a non-bonding pair automatically make it unsymmetrical?
Not always.
Maybe usually. I feel like that was a pattern. Then I started thinking that.
See, that's kind of a bad approach. You're trying to like find things to memorize.
Find patterns.
Yeah, I mean, so that's an important way of approaching things, right? Scientists do that all the time, look for patterns to try to figure out what's going on. But instead of just trying to find something to memorize, I just want you to look at each molecule individually and make up your mind about each one.
Mhm.
So what about this one? We have 4 regions of electron density, right? So it should be tetrahedral. And every bond angle here is greater than 90. It's about 109.5 degrees. So this molecule right here is symmetrical, right?
Mm-hmm.
What if I now change this? So now it's no longer symmetrical
Right.
because that's a different atom than these other 3.
Mm-hmm.
So right now it's not symmetrical. So if it has any polar bonds whatsoever, it's going to be a polar molecule. Say the green one was a rocket and the other 3 are not. It's going to move it. Say the 3 white ones are rockets and the green one is not. It's going to move it. But if they're all polar, chances are that these will be more powerful rockets than, say, that one, and it will actually move. So it's going to be a polar molecule. So let's see. Here's one of the more complicated molecules that we have in the chapter there. So this is a carboxylic acid. So this molecule has a triple bond here, has a double bond here, and the blue ones are supposed to be oxygen, the white ones hydrogen, the black one's carbon. So I'm looking at this carbon right here, and I have 1, 2 regions of electron density, meaning that this should be linear right through here, right? Looking at this central atom here, I got 1, 2 regions of electron density. So again, this should be linear. Looking at this carbon right here, I have 1, 2, 3, 4 regions of electron density. Okay, so this should be tetrahedral. Looking at this carbon here, I have 1, 2, 3 regions of electron density. So this should be planar trigonal. So here's the trigonal, and you can see it's planar. Then I look at this central atom. I've got 1, 2, 3, 4 reds. 2 of them don't have atoms. They're non-binding electron pairs. So this atom right here is bent. Bond angle is being about 109.5 degrees. So is this molecule symmetrical?
No.
No way, it's quite complex, right? So now let's look at the difference in electronegativity. Between carbon and a hydrogen, it's about 0.4. It's not electronegative very much, so it's nonpolar. Here the difference in electronegativity would be 0. Same thing here. Other nonpolar bonds over here. This is nonpolar over here. But then when I go from carbon to oxygen, that becomes a polar covalent bond. And from oxygen to hydrogen, it's another polar covalent bond. And on this side, I have another polar covalent bond over there. So I have these 1, 2, 3 polar covalent bonds that can act like rockets. But is this a symmetrical molecule?
No.
The answer is no. It's an asymmetrical molecule with polar bonds, so it should be a polar molecule. This molecule, by the way, would smell kind of bad. You guys can smell it?
Do we have to classify like lone pairs as polar or non-polar?
No, lone pair is not polar or non-polar because it's not a bond.
So it's just like that you can't classify as anything.
Yeah, because it's not a bond. Yeah. Electronegativity is only for bonds. So, let's see. Thinking. Okay. Answer key. Let's see what this does. That one. Waiting for Microsoft Office to launch.
So sorry. So the thing that you gave us, the sheet of this stuff.
Yeah.
I noticed that like the sheet, it says like for trigonal biplanar, it said like 90 degrees and 120 degrees, but like on your homework you also said it's 180 degrees. So I wrote that in.
Right.
But like yeah, I guess how come it's not like on the sheet? And then I guess I'm just trying to understand.
Because I stole the sheet.
Yeah.
I went to the internet, I found the sheet and I stole it.
Yeah,
I'm not a graphic artist. I don't have time to make all that stuff. Yeah.
But so it's pretty much just saying like this to this is 180 degrees. That's what it's
Yep.
trying to say.
Exactly.
Because I see like over here it's like yeah, okay.
Yep.
Okay.
Okay, so here's the answer key to homework 11. Okay, so we can apply some more advanced stuff over here. So hydrogen chloride, for example. How would you find out if that's a polar or non-polar molecule?
Do the bond.
Looking at it,
You look up the difference in electronegativity, right?
Right.
And if the difference was greater than 0.5 and less than, say, 1.7, then that would be a polar covalent bond. So that is a polar covalent bond. And is it a symmetrical molecule? No. So therefore, it's a polar molecule. And it would dissolve in water. Then if I look at carbon tetrachloride and see it's tetrahedral, is it symmetrical?
yes.
So it's going to be a non-polar molecule. Now the difference in electronegativity between carbon and chlorine is about 3, I don't know, what is it? 1.2 or something like that. So these are polar covalent bonds. But the way they're situated in space, it's simply going to cancel each other out. You're going to have to unshare screen, right? So this would be an example like carbon tetrachloride. It's symmetrical. So even though these are rockets, I fire all those rockets all at once, it's not going anywhere. They simply counteract each other. What about this next one, dihydrogen carbon dichloride? Is it symmetrical?
Symmetrical.
Okay, so what is the actual shape?
Tetrahedral.
Tetrahedral.
Tetrahedral, so the bond angles are what?
109.5?
Right. So they're not 90 degrees, are they? So this is not 90 and this is not 180. So here's a model of that. So these are polar covalent bonds. These are non-polar covalent bonds. So I have two rockets. If I fire these two rockets, it's going to go somewhere, right?
Mm-hmm.
So this is a polar molecule because it's not symmetrical. So nitrogen trichloride, okay, is pyramidal. Is it symmetrical?
No.
And is this really 90 degrees right here, or is it really 109.5?
109.
Right. So when I look at, wait, what molecule is this again?
Purple.
Yeah, okay. So this is pyramidal, right? If you look in different books and online, they'll tell you stuff like trigonal, pyramidal, but it's just a pyramid, that's all, okay? And so, is it symmetrical? No. Because of this non-binding electron pair, it's not flat, it's not planar. So you're taking these rockets and you're pushing them down like this so they don't cancel out. So this is a polar molecule. If these bonds are polar, what if the bonds are non-polar? Well, in that case, there is no rockets to fire. If I go back to I gotta click so many buttons. If I go back to this right here, I'm not asking in this particular homework about polar bonds, but this is a non-polar covalent bond. Electronegativity for chlorine is 3.16, for nitrogen is 3.04. So that's the situation with this molecule. It's not symmetrical, but it's also not polar because it doesn't have any polar bonds in it. Okay, carbon disulfide. 2 reasons of electron density is linear. Is it symmetrical? Yeah.
Yep.
So that's going to be a non-polar molecule. Oxygen dichloride. How many reasons of electron density?
4.
4. So this central atom has 1, 2, 3, 4 reasons of electron density. So it really should look like this. So the shape of this is bent. Now, is this a symmetrical molecule?
No.
It's not symmetrical. So if these are rockets, it's going to be a polar molecule. So we'd have to go back and look. What kind of bonds are between oxygen and chlorine? So if those are polar bonds, then that's going to be a polar molecule. But you see how deceiving it is to look at a 3-dimensional object on a 2-dimensional surface? And you may be thinking, oh my God, Harry's trying to trick us. No, that's just the way the world is. Yes, the world is trying to trick you. So diphosphorus tetrasulfide. So now I have 2 central atoms, and they're the same. So at each phosphorus, there's going to be 3 reasons of electron density. So the bond angles here, it's going to be about 120 degrees, right? Is it symmetrical?
No. Yes? No. No. That's what I was trying to ask, I think. Like, does a double bond make it like non-symmetrical? I guess I was asking if it makes it non-polar.
Okay, well, I just like to say this. Unless you're in politics, you cannot say yes and no at the same time. So here's a model of it, right? So what we know about resonance, that double bond I could have put here, or I could have put it here. So in fact, this is not really a single, that's not really a double. They share characteristics of each. So in effect, these 2 bonds are the same. Now, same over here. These 2 bonds are the same. So now does it look symmetrical to you?
Yes.
It does. So if there's no polar covalent bonds, then there's no way it's ever going to be a polar molecule. If they are polar covalent bonds, these 2 rockets over here are going to exactly counteract these 2 rockets over here. It's going to go nowhere, and it's a non-polar molecule. Okay, share. So this is the same situation right here. So the difference is that the double bonds are with an outer atom. Here the double bond is with 2 central atoms, but nevertheless it's the same shape and it's symmetrical. So then with sodium phosphide, there is no central atom. So here I'm just trying to get you to understand, how do we write Lewis structures when there's an ionic bond? This right here between the cation and the brackets right there represents the ionic bond.
As ionic bonds, you wouldn't draw a Lewis structure. I mean, that
Well, this
kind
is
of
how we do it. This is the Lewis structure for it.
atom.
So remember, I was trying to get you to draw even before we did all this in the previous chapter.
Yeah.
Purposely, I separated it. So you were drawing Lewis structures of elements and ions,
Mm-hmm.
right? So that's all we're doing here, putting 2 ions together. Then after we learned all the more complex ways of drawing covalent bonds, then we could do the polyatomic ions. So looking at the formula over here, so between the aluminum and each nitrate is an ionic bond. So here we're representing the ionic bond this way with those brackets. But between the nitrogen, which is a nonmetal, and the oxygen, which is a nonmetal, that would be a covalent bond. So this is how we designate covalent bonds. Same thing, right? Same exact way. So now I'm looking at the nitrogen. I got 3 reasons of electron density. Good look. And I'm limited by what atoms I got. I can't believe I need actually more atoms. It's ridiculous. I have well, pretend that this is the nitrogen. Oh. Pretend that this is the nitrogen, and these are the 3 oxygens, right? Okay. So all of these bonds are the same because of resonance. I could have drawn the double bond here, or here, or here. And so it's planar and it's trigonal, right?
Mm-hmm.
So now, does it matter whether these are polar covalent bonds or non-polar covalent bonds? The answer is no, because this is a polyatomic ion. So the attractive force is between this negative charge and that positive charge. So if somebody asks you, is a nitrate polyatomic ion polar? Your answer would be yes, it's so polar that in fact it's called ionic. Make sense?
Mm-hmm.
Okay. Okay, thank you so much. Let's see. That's homework 11, homework 12. Okay, so in homework 12, I am asking you to, is the molecule polar or non-polar? So why is this molecule right here polar?
Because it's apparent that hydrogen's throwing it off.
Right, so it's not symmetrical,
Mm-hmm.
and the carbon to chlorine bonds are polar. So I got 3 rockets and 1 non-rocket. It's going to move. So why is sulfur dichloride polar?
It's bent.
That's right. It's also not symmetrical. It's bent. And the sulfur to chlorine bonds happen to be polar covalent bonds. If they turned out to be non-polar covalent bonds, then this would still be a non-polar molecule. So why is this non-polar?
It's symmetrical.
Exactly. Exactly. What about this one?
Symmetrical.
Also symmetrical. Okay. And this one, is it symmetrical?
Yep.
So it's non-polar. And this one is ionic. And this one,
Ionic.
I
so here's one of the problem I find with other textbooks, and you just start searching online. They don't go through all these specific examples. So if you look at the formula, I can tell that this is an ionic compound because there's a metal and a bunch of nonmetals. So if you see one ionic bond, you name it as an ionic name, right? By that style. Also, you can do a Lewis dot structure the same way. So potassium itself is ionic, and so is phosphite. Because the attractive force is between that negative charge and that positive charge, making it an ionic attraction. So is phosphite itself symmetrical? No, but it doesn't matter. Is this symmetrical?
No.
No, because this part is not symmetrical. Is this symmetrical?
No.
Nope. What about this one?
Yes.
4 reds, they're all the same. So it should be symmetrical, right? Tetrahedral. Okay. That was 12, right? Okay, let's see. Okay, so one little detail. Iron is in group 8, right?
Yes.
So it should have 8 dots around it if it's an element. If it forms a +3, that means it lost 3 dots, so it still has 5 left over. So with these last ones, I'm just trying to get you to think about organic compounds a little bit. So all this part of this butane nitrile over here is non-polar. It's very, very slightly polar over here. And you know what's really interesting about nitriles is we use them because they can dissolve a non-polar molecule a little bit, and they can dissolve a polar molecule a little bit. If you didn't have molecules like butane nitrile, you couldn't get those 2 molecules together to have a chemical reaction. So here's an alcohol. Here's a carboxylic acid. Here's a diene.
If a bond was 0.49, would we call it nonpolar?
Which one now?
If a bond was 0.49, would we call it nonpolar? Or will you not ask us something like that?
Well, theoretically, because I gave you the cutoff of 0.5, then it's nonpolar. But truly, is there a difference between 0.49 and 0.50? The answer is no.
Not according to the uncertainty principle.
Are you sure about that? Are you
Yeah.
certain? You're certain about that? Okay. So here's some resonance structures. And then for the biochem students, you had expanded octets. Chem 100 students didn't have that. So if you look at this right here, it's perfectly symmetrical. And this right here is not perfectly symmetrical. So now if these are polar covalent bonds, which they in fact are, that means that It's asymmetrical. It's got polar covalent bonds. It's going to be a polar molecule. This one over here, it doesn't matter whether the bonds are polar or non-polar because it's symmetrical. So any questions about any of those?
Mm-mm.
Okay. Let's see, that's 13, 14. Okay, so here we're balancing reactions again. So will this reaction happen? What do you know about oxygen?
Reactive.
So will it go that way? No. Matter of fact, if you have aluminum screens on your windows, they were first shiny and bright, and now they're dull and gray. That dull and gray substance is aluminum oxide.
Oh.
Is it a redox reaction?
Yep.
Yeah, how do I know that? Because I'm going from a +3 to a 0. That's enough to tell me right there. But if I ask you what happened to aluminum, it went from +3 to a 0, that means it gained electrons, so it got reduced. Make sense?
Yep.
So oxygen must have gotten oxidized. Okay, so will this reaction happen? The answer is yes, because you're forming a gas. That gas is just going to float away, never being able to come back and join the reaction again. So that reaction will happen. It is a redox reaction because it's the aluminum going from a 0 to a +3. So aluminum got oxidized. What is the oxidizing agent? The HNO3.
Mm-hmm.
Is it safe to see a pattern here then, or no? Like, well, because you kind of said like if it creates a gas, then it's, you know, the gas is always going to leave.
Right.
So is it safe to say that if every time it creates that H2 gas, it would be like in the correct order, or no?
Sure. Yeah.
Because I was just kind of confused about the left to right part for sure. I wasn't like.
Mm-hmm. Okay, so that one's more simple. Okay, what about this one? The reaction will happen because you're forming a solid, right? That's a precipitate. So try to link all these together. Remember I was telling you, you take two, say, liquids and you mix them together. How do you know that a chemical reaction is actually happening? Okay, so heat can be given off or absorbed. In other words, a change in temperature. You see bubbles, which would represent a gas. You see a precipitate form, which is what we're looking at here. So link all that together if you can. Is this a redox reaction?
No.
Because calcium was a +2, it's still a +2.
Yep.
Cyanide is a -1, it's still a -1. Nothing happened. So here the hint was that zinc is more reactive than mercury. So here's zinc, it's more reactive than mercury. So if I do go in that direction, I get a more stable metal formed. So this reaction will happen. Do I expect you to know that zinc is more reactive than mercury? No, not necessarily. That's why I gave you the hint here. So here's an acid-base reaction. Okay. Now, how do I know that this reaction will happen? Bases are very reactive, acids are very reactive, and water is what?
Stable.
Stable. Exactly. Here, I'm comparing magnesium with silver. Obviously, silver is extremely stable, so this reaction would happen. So what's happening to magnesium?
Oxidized?
It's going from 0 to a +2, so it's getting oxidized. So the oxidizing agent would be silver sulfate. And why would this reaction happen? Because you get more stable.
Is it getting more stable because silver is like by itself? Or like, why exactly is it getting more stable?
Because you're forming silver, which is a very stable metal. That's why.
Okay.
If I had to put energy on this side or this side, I would put energy over here. Because you have more potential energy here than you do over here. So by the law of conservation of energy, energy would be given off. Okay. Let's see. So any questions about any of these? No?
No.
Okay.
Balancing start annoying me.
Yeah. You know, I did the best I could figuring out ways for you guys to learn how to balance, and ultimately,
Just gotta do it.
you just got to do it. That's right.
Well, starting with polyatomic ion for sure helps.
Yeah, that that made it so much simpler. Well, it's still not simple, but
Well, my chemistry professor used to give us like crazy problems to balance, so like that's how I got good at it. Like insane ones. It'd take like so long to figure it out.
You took the 161, 162 or something?
I just took 161, but it was just really hard 161.
Yeah. Did it have you balance it in acidic solution versus basic solution?
Yeah, and then she just would make it really complicated, like lots of fractions to fix and stuff.
She would make it that way, or chemistry is just that way?
I mean, you would choose to put that kind of problems on the exam. It's not necessary to do that, right? Like you wouldn't do that.
You're giving me such great ideas.
We're supposed to have a coronavirus. Don't do it.
Now, I mean, it may not seem like it to you, but what I try to do is this: if I can instill the basics in you, right, then you can apply that to more complex problems.
I agree.
And many of you will never have to do that, so the best thing to concentrate on getting the basics, right?
Well, I just feel like it's unfair to give us like basics on our homework and our quizzes and then give us something really complex on an exam. You know, like at least give us some practice so we can run through something complex and then complex, right?
You're giving me even more ideas. Thank you so much.
No, go read her Rate My Professor and then you won't want
I would hate to even read mine, so yeah.
Somebody wants you to run over the quiz. I don't know. In the chat, she said it.
Yeah, quiz 9.
Oh, you want to look at quiz 9?
Yeah,
Yes,
it-
please.
Okay.
over number 4 and number 10. They're asking you to go over number 4 and number 10.
Write that down so we'll get to it.
Oh, what's number 4 and 10?
Quiz 9, number 10.
Number 4. Yeah, quiz 9, number 4, and 10.
Oh yeah, number 4 really confused me.
Quiz 9, number 10.
And number 4.
Please.
Do you have any questions on this last homework right here?
No,
No.
What about the math part?
it's okay.
The math for this one is like simple.
Yeah, not too
I mean, keep in mind that you have only 3 conversion factors, right?
right.
Yeah.
So, yeah, okay. Now,
I was kind of confused about this like abbreviation table that you gave us with like the AW, GAW. Are you gonna like use those terms?
yeah, I might. So what's the AW for hydrogen? How do you find that?
What's the individual mass?
Right. So the units are going to be AMU. You look on the periodic table, it's going to be 1.00794 AMU.
Okay. And then
And
so
the GAW would be 1.00794 grams. That would be for a mole of hydrogen atoms.
oh, okay.
And if I had MW, then that would be a molecule for hydrogen, which would be 2 hydrogens. So that would be 2 point something AMU. The GMW would be 2 point something grams.
Okay. Okay.
Yeah? So it's pretty simple.
Okay.
And then from that, to get to formula units, you have to do like Avogadro's number.
Right, if you're going from moles to formula units or atoms or molecules, then you have to use Avogadro's number.
Okay.
So it might take me a minute to be able to find these homeworks. I got to log into La Lima. We got to wait for La Lima. And we'll go here, testing quizzes. Unit 3, quiz 9. How can I do it without, oh, I know. Edit, I guess, okay. Then share screen. Okay, so homework, let's see, number 4 you were talking about, right?
Mm-hmm.
Okay. So how many regions of electron density around the central atom?
0.
0, because there is no central atom, right?
Yeah, that's right.
I want to
That's
ask if
Loudly,
polar,
but
Huh?
I want to ask is a polar or non-polar? It's confused.
There's
Okay. So far we got that there's no region of electron density is because it's diatomic, right?
Yes.
So now if all of the bonds are polar, is the molecule itself polar? That means that you have only one rocket in there. If you fire that rocket, it's going to move, so it's going to be polar. The molecule is polar.
Yeah, but I choose yes, but because the answer said it's wrong, it have to be no.
Oh, is that right?
Yeah, so that's why I asked you.
If you only knew how many mistakes I get over here.
Oh yeah.
If all of the bonds are polar, is the molecule itself? Yeah, I have yes here.
But in my quiz,
In your quiz, you put yes and you got it wrong?
oh no, I'm okay with that. I'm sorry.
Because if that's the case, that's not fair, and I'll get right to President Trump and find out. We'll get to the bottom of it. Okay, so we're done with number 4.
Oh yes.
Okay, then number 9, you were saying?
10.
Number 10.
Right? Whoever asked that, I don't know.
So this is for biochemistry, right? Okay. So how many reasons around the center of atoms? You got 1, 2, 3, 4, 5, 6, right? And the shape is simply going to be linear. Mm-hmm. And if all the bonds are polar, is the molecule itself polar? The answer is no, because it's symmetrical.
It's symmetrical.
Yeah? Oh, now I know why there's so many. Okay. See, this right here was originally an exercise that you would actually have the models in the STEM Center.
Oh.
So for extra credit, I would have you go there and actually play with the models and answer questions on a sheet. But now we can't do that because you guys will just leave viruses all over everything. Because that's how you guys are. You just putting viruses everywhere.
Millennials.
Yeah, millennials. The millennial viruses. Yeah. Okay, so that takes care of all the homework. And I think, let me just check my schedule here a minute. Tomorrow's Wednesday, right?
Yeah, is the exam tomorrow? Because I know you said Wednesday, but did you mean this Wednesday?
Yep, Wednesday and Thursday.
On Thursday, okay. I mean, that makes sense.
So behind, it's ridiculous. So I will be sending you an announcement on the homework. You'll be doing it on La Lima at your house. Okay. And anyway. So yeah, so tomorrow I can do another Zoom on chapter 4. Thursday I won't be able to because Thursday is the rest of the science fair.
That's great that you guys are still doing it.
I know. It's so much work, but some people really stepped up to the plate. I mean, it's just unbelievable what these people did.
Cool.
And the amazing thing is, here's the amazing thing. I've been a head judge for all the biology stuff for 20-something years. I've been doing science fair for probably 30. My very first science fair student was the keynote speaker last year. He's now a thoracic surgeon at Queens and the medical school.
Wow.
And then our head judge for senior research, because I don't want to do it because I'm so dyslexic, I can't find anything. She was a Kamehameha student like maybe 10 years ago. I judged her. Now she's our chief judge. She's a UH professor now.
Yeah. My parents should have sent me to private school. Damn it.
That's what I gotta. I tell my relatives. I said, you went to Kamehameha. That's a private school. You had a privileged education. So stop talking smack about Kamehameha. It's a good school.
It's a great school. I wish on all my might I went there. It's a great school.
Yeah. Then the other thing is that the guy who did most of the work making the online platform for us to do the science fair was in the science fair as a student, I think 4 years ago.
Like, who does the science fair? I've never heard anything about like the science fair in any of my classes. Like, do you have to join a club or like how does it work?
No, it's put on by the Hawaii Academy of Science.
So like anybody can do the science fair, or?
No, it's only for school kids.
I mean, yeah, like student wise, but like any student can do it, or like how does
Yeah.
it? Oh.
Yep. So in the finals, then, you know, at the state level, so you have school level, then you have district level, and then the state level. At the state level, Twinahoe kids and Farrington kids are right next to each other, and yeah,
Right.
yeah.
Good stuff.
Farrington's also a good school if you get into the right gang. Sorry. Yeah.
Oh my.
So my wife taught chemistry and physics at Farrington for 13 years.
Wow. Wait, is there like a college science fair, or we don't do that?
There is a college science fair. There's one in agricultural sciences that I help judge. There's another couple other venues for that, but there's some. But it's not like a big thing like the state science fair.
Yeah.
Yeah. And the kids who win the state science fair, there's usually about a dozen kids that one way or another get to go to the international science fair. So I've taken the group there several times, my wife and I, and you get kids from Kalihi Valley that are meeting kids from Saudi Arabia wearing white robes and stuff like that, and they're hanging out and partying. It's like, it's crazy, the kind of things that can happen. Yeah. So that means Thursday I can't do it. Friday's a holiday. I don't know if that will affect you guys or not. So I'll just try to do Wednesday. Wednesday, I'm gonna start Unit 4.
Okay. Are you thinking like the same time as class, or like a little bit later?
Well, the face-to-face class was at 1:45, and so I can't do 1:45 on Zoom, but I can do 2 o'clock. So yeah, that's why I do that. And I just invite everybody.
Yeah.
Even Chemistry 100 students, because they study the same material, just oftentimes not in the same depth as Chemistry 141. Yeah.
That makes sense.
Okay, so today's Tuesday. I feel like I'm getting sucked into the computer.
Don't do it.
I've been on Zoom since noon.
Yes.
Yeah. It's crazy.
Okay, so she wants to know, like, what time to what time is it going to be open?
The exam or the
Yeah, the exam.
from 9, so far I'm thinking from 9 o'clock in the morning to 9 o'clock at night.
On Thursday? So 9 a.m. Wednesday to 9 p.m. Thursday? Or no?
No, on 2 different days.
Oh, okay, okay.
Yeah. So I'm not going to stay up past 9 o'clock watching exams or anything.
You go to sleep at 9?
No, that's when I leave home to go party. You haven't heard about the COVID-19 party?
I have. I was there. I didn't see you.
Yeah. No, but there are people that that aren't working. They lost their jobs, and there's people that are working twice as much as they did before because they're in the health profession.
Well, my friend works for the state legislature, and he's working a lot also.
All right.
Yeah. I have no job. I feel like, guys.
Yeah, my cousin's like, she's an ER nurse and she's getting slammed.
Yeah.
So it's like either you're like depressed and working every day, or you're depressed and like poor every day.
Yeah. Well, there's, I've always told people that, I have friends that they make a lot of money. They have like their own companies and stuff. I've always told them, it's like, yeah, there's 2 ways to become rich. One way is to make a bunch of money. And another way is to make not so much money, but you work so much you don't have time to spend money.
Yeah.
And that's unfortunately the life I chose.
I know. I don't know whether to tell people like be grateful you have a job, or like be grateful that you don't have a job. Like I just get to sit at home all day now, but like, also I'm probably gonna start starving at some point. Just kidding.
Well, I've heard that
all the dates.
bugs are quite nutritious, by the way.
I know. I'll eat grass all day if I have to.
Yeah. Okay. Well, anyway, so what we got about 10, 15 minutes more. Is there anything else you want me to go over?
Hey, Professor, are you free later on today? Because I just finished work and
Oh, you got muted somehow.
I had a phone call. I'm on my phone.
Oh,
But I just finished work because I'm working in the hospital. But I have some questions about before I take the exam tomorrow. And I'm on my way home right now. And I just got into you guys' chat.
oh. Well, this is all recorded, by the way.
Yeah.
It will take me a while to get it up on the YouTube channel. It takes about 30 or 4 minutes for Zoom to process it, and then it takes another, I don't know how long for YouTube to process it. So, but it will be up there later on today. But do you have any questions right now?
Well, let's see. I do, but I just have to look through it right now. I just kind of just jumped in and see what you guys were talking about. Because I thought it was at 3, but did you guys start at 2?
Yeah.
I thought it was at 3 too. I do have a question, but did you go over all the questions on homework?
Yeah.
And the stuff? Okay, I'll just kind of review it then. I'll probably just email you if I don't get something.
Yeah, that's easy to email me.
Till 9.
No, he's gonna tell him that. He's gonna be like, which online?
Yeah, I've been sucked into the computer.
Okay, well, I'll just email you then because I have to look through it because I did circle some stuff, but I don't know what exactly. to ask you yet.
You have like one in the beginning that we could just do now that might help you solve other problems.
Can I ask something?
Mm,
Sorry, girl. I'm gonna ask
okay,
something.
how about
Okay, it says neutralization reactions are also double displacement. That's true for all? Or no?
Yes, that's a pattern.
Thank you.
how about homework 11, number 10? I was kind of lost on that.
Okay,
Or maybe it's just the aluminum nitrate.
11.
Oh yeah, he went over that on the recording.
You did.
Yeah.
Okay.
Yeah, but we can do it again because nobody's really asking more questions. So
That's true. I'm listening.
homework
So-
11, number
So
10.
I was like, because Colby is also my coworker. She's also in the online class with me,
Uh-huh.
and I don't know. Maybe this is a dumb question, but
We like that.
with the COVID, sometimes I tend to ask blunt questions, but when you have the covalent bonds, it's how should I? Never mind. Go ahead. Never mind. Go ahead with your presentation. Never mind.
So homework
I'm not really.
11, number 10.
Yeah.
So yeah, this goes back to actually unit 2. Remember at the end of unit 2, I'm asking or showing you how to draw Lewis dot structures for atoms and for ions.
Right.
So sodium is in group 1, so it has 1 dot around it. But then when sodium reacts, it forms the +1 ion, and it loses that. So it has no dots.
Wait, we're on homework 11, number 10. I have the aluminum nitrate.
Oh, I'm sorry. I
Oh,
opened up the wrong one.
Because I was like, that doesn't look like what I have right now.
Wow. How did I get that? Oh, that's our super old one. I'm sorry.
fall 2012.
Homework 11.
That's the ionic bonded molecule that we were confused about.
Okay. Come on. Okay, this one?
So here, can I tell you first and see if I'm doing it correctly? So nitrogen is 5, right? Because it's on the wait. So you add 5 for nitrogen, and you add 6 times 3 will give you 18, right? That would,
Uh-huh.
and you add 3 plus 3 for the aluminum
No,
because it's
no, this is only for the polyatomic ion. So can you see what I have on the screen right there?
yes.
Okay, so you got 3 oxygens in our group 6, so that's 18. 1 nitrogen in group 5, so that's 5. And that negative
Right.
1 charge, you have to count that as well. So that negative 1 charge came from the aluminum. So aluminum is giving up 3 electrons, which is why you need 3 nitrates, because each nitrate is going to take only 1.
Okay. Yes.
So what we're trying to do is get the Lewis dot structure for the polyatomic ion itself. Okay. So the Lewis dot structure for the aluminum ion is just that.
Okay, that's what I got.
Yeah.
But I just didn't draw the dots because I was lost. Now I know.
Okay. And you know why there's a double bond there?
Yes.
Okay.
Because don't you need to 1, 2, 3, 4?
Is there not too many dots on that O then? Where the double bond is?
Oh, you're right.
Barely. Barely ever.
There we go. That's the way it's supposed to look. So before the double bond, nitrogen had only 6 dots around it. So you had to share some from one of the oxygens to give it 8.
Uh-huh.
Make sense?
Tetrol. Okay.
Yeah. And so because of resonance, all 3 of these bonds are actually the same. Because I could have put the double bond here, here, or here. And so because of resonance, all 3 of these bonds are the same. So each of those bonds is about 1/3 double bond character and about 2/3 single bond character. So looking at the central atom, you have 3 regions of electron density around the central atom, making it planar trigonal.
That one I get. Okay.
Got it? Okay, cool. So if somebody asks you whether this is nonpolar, polar, or ionic, you would obviously say ionic, right?
Okay. Yes.
So looking at the formula right here,
Oh, because of the ion. Okay, go ahead.
because this is a metal and these are non-metals.
Right.
So when it comes to naming that, we automatically name it as an ionic compound. And when it comes to doing Lewis structures, we do the same thing. So this right here represents the ionic bond, and so does this right here. So covalent bonds are represented by the lines. See that?
I was about to say the aluminum. Okay.
Mm-hmm. So between aluminum and nitrate is an ionic bond. Between oxygen and the nitrogen is a covalent bond. And if you wanted to, you could look to see at the electronegativity, is it nonpolar, polar, or ionic? So in this case, these would be polar covalent bonds, but it doesn't matter anyway, because it's an ion.
Okay.
So if you ask us what kind of molecule it is, we're just gonna say ionic.
Who knows what people would ask, you know?
That's what I have to figure out.
You got to keep in mind is like, I have to prepare you for taking other courses. I can't just do my own thing and pretend like nothing else exists.
One course at a time.
Yeah. So you
Okay.
maybe,
Can
say
I
you
see
want to
number
go into
7?
nursing and you got to go take an NCLEX exam. They might ask you what kind of bond that is. I don't know. They ask you anything.
Stress
You go ahead.
Can I see number 7? Because I drew it differently with my I wonder if I could show it to you here. You know, I can't just do the Zoom stuff. How do I show you my picture?
Pick it up, girl. Just like
There we go. It's too high tech for me. Number 7, I drew it like that.
is it
Is
P2?
it wrong? Yeah.
That's not wrong. That's, you have 2 double bonds, right?
Yes. I got 2 double bonds for each P.
Oh yeah, no.
But I have a total of, or maybe I might, see, that's what my question was. Sometimes I confuse myself because like each,
Forgot that P is a double molecule in the middle, so there's already 1 bond there, so you don't need 2 doubles because then it's gonna be too much.
oh, I get it.
Yeah,
Yeah.
I do that
Okay.
too. Especially when you start spazzing out like this deep in it, you're like just start doing all kinds of stuff.
I'm like overthinking some stuff sometimes, and I'm like, what am I doing now?
Yeah,
Well, what you want is for every atom to have 8 dots around it. Unless it's a small atom, then you want only 2, right? Like with hydrogen.
Right.
So the way to approach that is you don't draw any double bonds unless that's the only way you can satisfy the octet rule.
Yeah.
So don't like do a Lewis structure and then just start adding double bonds because you think it looks cool.
I think I just counted too much.
You only do it when you have to satisfy the octet rule. That's the only reason why you would do it.
Okay.
So like for here, you can see this, right? Like
Yes.
if I take that double bond away and I put those electrons back onto the sulfur, then that phosphorus wouldn't have 8 dots. It only has 6.
4, 5, 6.
That would be a
7.
sad phosphorus.
You said that that molecule is nonpolar, correct?
It's nonpolar because it's symmetrical.
I guess I have to take off on Thursday to do my exam.
You could do it tomorrow.
I work Monday to Friday, so I have to take off one of these days.
It'll be open till 9.
Yeah, that's true.
Thanks for helping in the healthcare.
You know, it's my. I can't get off. But it's all good. So, Professor, did you watch The Strain or not yet?
Did I watch the who?
The Strain, the one on Hulu. If you have Hulu,
The Strain.
yeah, you have to watch that.
No, but there is a Netflix series called Pandemic. It came out.
No, I did not like that at all.
Yeah, well, it's more factual. It's more scientific. And yeah, it came out before the pandemic came out.
Yeah. Oh, so you think that the information is accurate? I mean, you know the information is accurate. I was wondering.
Yeah, well, so there's a lot of discussion with the research group going on at UH. And anyway, we totally believe that this is a wild type or natural strain that came out of China.
Right.
Because they look at the sequence and they can tell that the sequence wasn't manipulated. It's a natural virus. But
Oh,
there's too many things that make it look like China could have taken this wild type virus and purposely, logistically spread it through the world.
so it wasn't scientifically made, but it could have been like scientifically spread.
Exactly.
You know what? They were just making new antibodies, and it just got all haywire for the flu. They're just trying to make a vaccine for our next flu shot that it just became the virus.
Forever about if vaccines were dangerous or not. When we did that chapter, she doesn't know, but I'm like, is it not causing like viruses to evolve? But she's way smarter than me, so I just let her go.
Well, the good thing about this virus is that the virus doesn't mutate that much.
Mm-hmm.
But they said you can get it for the second time if you were negative when you get cured. You can still get it again.
That's weird, huh? Well, I guess that's like the flu, right? The flu you can keep getting.
But anyway,
True.
so because it doesn't mutate much, they should be able to come up with a virus. Word for it.
All right. Well, I have to go, but thank you for letting me ask some questions. I might just have to email you because
Yeah, sure.
my partner is calling me, also known as my husband. But he's like, I'm not here, hurry up. So I have to leave. I'm still at work waiting for him, and now he's downstairs.
Okay, thank you, Vanessa. Take care.
Thank you. Bye.
See you.
Yeah. I just be talking to people like I'm ready to be the professor.
They should come up with an injection fairly soon for this virus.
Yeah, and then they're gonna make us all get it and inject their poison into us. I'm gonna say no. Are you
Oh,
laughing?
God. Yes.
I don't
But
like,
you're anti-vaxxer.
I don't do that. I'm not an anti-vaxxer. I'm an anti-everything. Believe that, boy.
Yeah. Well,
I
no.
don't use anything. I don't do cleaning chemicals. I don't do laundry detergent. I don't do shampoo. I don't do none of that. I'll get cancer by myself. I don't need your guys' help. Thank you.
The no shampoo thing is good though.
So bomb.
It's better for your hair.
No cleaning products too. It's really good. Everything smells really good.
Yeah, but we do need to keep everybody immunized because if you don't, then those anti-vaxxers are spreading disease all over the place.
Yeah. Disgusting.
So here's what happened with what was it that recurred recently?
Samoa?
Oh, smallpox. No.
Smallpox, yeah.
Yeah, with Samoa, because of that one preacher that went over there and told them don't get vaccinated or some shit like that.
So if you look at statistics, in order to keep something like that from spreading, you have to have at least 95% of people vaccinated. United States is at like 94%.
Yeah.
So that's why we're seeing every so often something gets out of control. And you know what's the people who are going to suffer the most? The people who didn't get vaccinated.
Don't at me. At least if I die, I'm going to get an A in biochemistry.
That's good. That'd be great.
Not a total loss. You know, my mom got a flu shot last year and she almost died. She got so sick from it that she almost died. Is that a coincidence?
There's a missing link that people are probably going to figure out because of this new virus. And that is some people don't even know they have the virus.
So she already had it?
Some friends of ours were in Australia. And when they were coming back to Hawaii, they're like, you know, we were in the airport in Australia. There was no restrictions anywhere.
Right.
Nothing. So they came over here and they started feeling a little bit sick, so they went and got tested. And so the husband was like, well, I had a cold, no big deal, for a couple of days. And the wife was like, well, it was more like a flu. And their 4-year-old kid tested negative. But they're quarantining, you know, self-quarantining.
Did they test positive?
Yeah.
Oh.
So some people respond like that people, and then some people just require, you know, emergency room treatment.
Right.
And the difference is most likely the person's immune system.
Yeah.
So many things like people who going into anaphylactic shock over peanuts and all this kind of stuff, it's all their immune system. So these people that are in intensive care, I think what they really need is to have something done with their immune system. Maybe immune system suppressants, I don't know.
Yeah. Or that, like, yeah, it could
Be
be
the difference.
some medication they're on, or I don't know. Because my friend, he works at the Senate, and somebody tested positive there, so they shut down the whole Senate and made every single person in there get tested. And every single person in his office was in direct contact with the guy who tested positive, but no one else tested positive. And they were all in direct contact with him for that whole week. So.
Yeah.
But they also took 19 days to get his results back in the state Senate.
Yeah.
Even for the senator. So I was like, oh, that's not good, probably.
Yeah.
It'd be faster now. It should be.
Should be, but
Well, we were, you know, United States, like all these other places, were unprepared.
yeah, for sure.
Yeah.
They knew it. If they listened to the scientists, then they would know to spend money on being prepared, but they don't do that. And the thing about China is right where all the politicians and all the rich people are in Beijing, 0 cases. 0 cases.
Such a coincidence.
And Hunan province is apparently open now already. They're all done with it.
That's nice.
When China says, okay, nobody come outside because of a virus, if you go outside, what are they going to do to you?
Shoot you.
Throw you in jail.
Exactly. They just freaking shoot you, that you disappear.
Oh yeah, they put you into that work camp that they have.
Yeah. Yeah, no, it's a very different place.
I've been trying to like avoid going to the grocery store, but like I don't know if I'm just like a spoiled human, but I have to go at least once a week. So I'm like, how are those people surviving? Rice?
Yeah.
I was talking to this one guy, and he goes, yeah, I'm not worried because I'm never going to starve. I'm a quarter Fijian. And
Is that a joke or?
yeah, it's a joke. I'm hoping it's a joke.
Okay. I mean, like, I feel like my body could feed off itself for like a while too, but like,
No, well, Fijians were known for certain aspects of post-war celebrations. I don't know a better way to put it that way, but yeah, so they were cannibals.
I mean, so like, I mean, technically, you have to leave the house every day, right? Now that's your house. That's a cool house you got there.
No, I'm 2 blocks away from UH Manoa, so this is my lab.
It's a nice lab.
So
Looks better than what we got at KCC. Only a little bit though.
yeah. Well, does anybody have any other questions? If you have, you can email me, and I gotta get this video moving to get it up
Okay.
online.
Wednesday, Thursday, 9 a.m., 9 p.m.
Yep.
Okay, thank you. That's
The
perfect.
format will be like just before.
I'm sorry?
The format will be just like it was on the other tests.
Yeah, on the Lima. Yeah.
Okay.
Yeah.
Can you explain for me the question 2 of the quiz 8? The SO2F.
Quiz 8. SO what?
The question 2.
Number 2 is about SO2.
Yeah, SO2F.
SO2.
F.
SO2F.
Yeah.
I don't know what you're talking about. Let me go pull that up. So that's quiz 8. Eight.
Oh, okay.
Number 2. Come on. Okay. Oh, okay.
Yeah.
So what is your question about it?
I mean, I don't understand. It's like because I have the answer is is symmetrical.
Yeah, so it's not
Yeah.
symmetrical.
It's asymmetrical, right?
Asymmetrical, right?
Yeah, because the answer, yeah, so
Oh,
asymmetrical.
I see what you're saying.
Yeah.
Okay, well, let me take a look at that. Okay, I'll have to see if that's throughout the whole thing or whether that's just in the one I'm looking at. Because I have 5 classes that applies to, so I have to go look to see if it's mistake is everywhere or just in that one place. Okay, I'll do that.
Oh yeah, yeah, I got that one down too. I put asymmetrical for that one too.
Oh yeah? Okay.
Symmetrical? These are funny.
So,
Sorry.
Okay, I'll look at that and fix it. Fix it. Yeah.
so how about the um um the REDS is 4 or it's 3 because it had like 25 covalent bonds.
What is that you're saying? I didn't hear what you were talking about.
I don't know how to write how to draw the structure of the SO2F.
Oh, okay.
Yeah, it tell me it had like 25 covalent bonds, right?
25.
What number are you on?
It's
SO2F.
Yeah, it's on quiz 8, number 2.
Okay.
yeah.
Yeah. Yeah, I think there's a typo in there somewhere. I'll have to go in there and fix it. Like I said, I don't know if this is on all of for every 5 of the 5 sections I have, or just whether it's just on yours. I don't know. I'll have to take a look.
Mine is right, I think.
Yeah. Okay, well, anyway, let's go to do our other work now. I have other work I have to do.
All right, thanks.
And so I'm going to end the meeting, and it's going to take a while for this to get posted, but it will be posted, okay? And if you have any other questions, just email me, okay?
Okay.
Now, like saying all the test exam times and dates to like avoid a million emails because I'm sure you're gonna get.
Yeah.
Yeah.
Well, I still have to go send that out, so that's another thing I got to do. All this stuff takes time. Anyway, so you guys take care, okay?
Bye. Thank you.
Stay safe. Okay, see you.
Bye.
Bye.